to rapid region series NEET that we are going to discuss today, that is oscillation and waves, that is one shot number 7. So hope you all are doing very well practice. Yesterday we discussed the thermodynamics. We solved some good number of the questions from the thermodynamics, previous year questions. Today we are going to discuss this oscillation and waves chapter, and I hope you all are doing very well preparation. So let's begin our today's journey without wasting any single second. So what are the topics? So as again, this is not a single chapter, these have two chapters. First is oscillation and second is waves. So we have a time of one hour, something like that, and we'll try to cover the most of the concept as much as possible. So if we talk about this oscillation chapters, what are the different basic terms that we are going to discuss today? The different basic terms related to SHM. If we talk about the oscillation will be having like SHM is there, periodic motion is there, oscillatory motion is there, but simple harmonic motion is the basic one. That is maximum questions will be asking from the simple harmonic motion. Next we have this time period of oscillating bodies. So what is oscillating bodies? We have so many oscillating bodies, but we'll be focusing only on the two oscillating bodies, that is spring mass system as well as time period of as well as simple pendulum. Third is types. Next we discuss for the wave, that is types of the wave, traveling wave, equation of the wave and its characteristics, and last part, that is standing waves. From class 12th you might be discussing this, like open organ pipe, closed organ pipe, those type of questions will be discussing in the standing waves. And last part is bits. So one good part of that, Doppler effect is deleted, so we don't have to focus on that. So let's start today's journey with some basic terms related to the SHM. So for example, we'll be dealing with one particular concept toward this, that is a particle is doing SHM in a such way that it is doing SHM about this x equals to 0, it is going to x equals to a. Okay, to right extreme it is going to x equals to a. So starting from x equals to 0, it is going to right extreme x equals to a, and coming back to left extreme x equals to minus a. So particle started from this particular point. Where the particle is starting, we define that particular point as mean position. So mean position is the particle about which net force acting on the particle is 0. So net force acting on the particle is 0, that is mean force acting on the particle about which the net force acting on the particle is 0. So at this particular point, if I ask you, so here x equals to 0, and this side, this is the right extreme, and this will be left extreme. So at particular point, suppose particle is over here, so this will be called as displacement of the particle from this mean position. So that will, we can write in terms of the x. The x will determine the displacement of the particle. So second is displacement. We have displacement of the particle. Third one we have, that is amplitude. What is amplitude? The amplitude will be the maximum displacement of the particle from mean position. How far it gone from mean position, that maximum displacement is what we define amplitude. This side also maximum displacement is also fine. This is x equals to a, amplitude, maximum displacement, and this side also x equals to minus a. So this is also maximum displacement, that is also amplitude. Next we got the mean position, we got the displacement, we got the amplitude. Next one, that what we gonna define here, frequency and time period. So frequency and time period. First let's discuss about the time period. So what is time period of the oscillation? So what is time period of the oscillation? Time taken to complete one oscillation. And what is one oscillation? Starting from x equals to 0, going to x equals to a, coming back to x equals to 0, going to x equals to minus a, coming back to x equals to 0. This is what we define one oscillation. This is what we define one oscillation. So time taken to complete this one oscillation is what we define time period. This will be having unit of time. Last part, that is next part, we have frequency. What is frequency here? Frequency is nothing but number of oscillation per second. So if I discuss this one, that is frequency. Frequency is numerically equals to f, and what is f? 1 by time period we have, that is number of oscillation per second. So in 1 second, how many number of oscillation is happening? To, fro, to, fro, to, fro. This will be called as one oscillation. So this f equals to 1 by. Next we have angular frequency. So what is angular frequency? That we know. Angular frequency, that I will be writing this omega. What is omega? 2 pi f. So this will be angular frequency, omega equals to 2 pi f. So these are the terms that we have in SHM. further term that we can also write here, that is we got the frequency, we got the angular frequency. From here we can also write here omega is equals to 2 pi by t. Now, force equation in SHM. So what is force equation in SHM? So SHM, so for example, if the particle is oscillating in such a way that this x equals to 0 and this x equals to a, and the particle is going this side, x equals to minus a. So in this case, if the particle is this particular point over here, distance of the particle from the mean position is x. So at that point, the force will be acting always towards the mean position. So here the force will be acting towards the mean position. If the particle is over here, the force will be acting towards the mean position. And that force is what we define, minus k into x. And what is k here? K is nothing but a spring constant that we know already. So F is equals to minus k into x, where x is the displacement and k is the spring constant. From this we can write Newton's second law of motion, that is mass into acceleration equals to minus k into x. So what is acceleration from here? So minus k by m into x. So when we are getting any SHM that is having the forces given in this particular term, that is the force equation of the SHM, where k is the spring, k will be the force constant, x will be the displacement from the mean position, F is the net force that is acting on the object. So here acceleration is minus k by m into x. Here acceleration I can write in terms of this, that is a is equals to minus omega square into x. Comparing this equation we are getting a equals to minus k by m into x and a is equals to minus omega square into x. So what is omega square? K by m. Then what is omega? Under root k by m, where m is the mass and k is the force constant. So this is the term from which we are getting the angular frequency. And once we got the angular frequency, we can calculate from here 2 pi by t. Time period we can calculate from here, that is omega is 2 pi by t. So here F equals to minus kx. This will give us equation of the force. From here we got this omega equals to 2 pi by t, and that omega equals to under root k by m, where k is the we can call it as force constant, m will be the mass. So frequency again 1 by time period. This will be 1 by 2 pi under root k by m. So, and what is time period? So time period from here is 2 pi under root m by k. So after solving this particular equation, that is F equals to minus k into x, or a is equals to minus k by m into x. So what is acceleration we have? The acceleration we got, that is minus k by m into x. What is acceleration? If I write in terms of the differentiation of this x, so we are getting acceleration is double differentiation of this d2x by dt square is equals to minus k by m into x. So this particular term I can write in terms of this d2x by dt square plus k by m into x is equals to 0. So this particular term is also we define the differential equation of the SHM. So this one is differential equation of the SHM. Differential equation of the SHM. Yes, question has been asked from this equation as well. So here k by m will be nothing but omega square. This will be omega square. So mathematically, if you solving this particular formula, that is this particular equation, if you solve the mathematically, so what will be getting? If you solve the mathematically, we'll be getting like this. X is given by a sine of omega t plus phi, or x is given as a cos of omega t plus phi. And what is a here? A will be amplitude. This is omega is angular frequency, as we know. T is the time, phi is the initial phase, and we'll be discussing what is phase over here. So this phi will be initial phase. So for example, if when to use this, if phi is equals to 0 and we are using this x equals to a sine omega t, it means the particle starts from mean position. The particle starts from mean position. Okay, the particle starts from mean position over here. So how the particle starts from mean position? So particle is at the situated the x equals to 0. We are giving the particle push in that direction, at which time at t is equals to 0, particle started from this particular position. So whatever the equation we are getting, that will be this particular equation, that is x equals to a sine omega t we are getting. So when the particle start from mean position. Second, in the second part, if particle start from, if we are getting phi value 0, and if I am taking this particular equation over here, so what is x value? X value you can write here a cos omega t. So in this case, particle starts oscillation from extreme position. Start oscillation from extreme position. So it will start oscillation from extreme position. That is, particle will start oscillating like this. It will keep on oscillating like this. So this is what we have, that is equation of the SHM at different point at which the particle is starting its oscillation. So moving next particular part, that is phase and time analysis in SHM. So what is phase and what is time analysis in SHM? So if we talk about this phase, so just now this phase, whatever the term that is inside the sign, that is what we define phase. So inside the sign, whatever term we have, or whatever term that is inside the cos, this also we define as phase. Initial phase will be 0. Initial phase will be 0 when the phi will be 0. Initial phase will be calculating when the t is 0. So for example, just now we see that when the particle start from mean position, we have x equals to 0. Like that, if I draw on this, the particle start from somewhere else. So I'm drawing one particular line. Please note it down this. So here this is some shortcut to get this equations of the SHM, because most of the students get difficulty here. Sir, we don't know how to write, from where we should write this. So suppose the particle start from here, what should we write like this? For example, let's say this is x equals to a by 2, and here we have a by root 2, and here we have root 3a by 2. This side, if you go on the negative side, this side minus a by 2, this will be minus a by root 2, and this side minus root 3a by 2. So let's say our particle started from this particular point. At t is equals to 0, it is moving towards this side. At this particular point, angle will be 0. Particle has reached over here, moving towards this side. At this particular point, this will be 30 degree. At this particular point, phase will be now sine 30, 1 by 2. At this particular point, phase will be now 45. At this particular point, phase will be now how much? 60 degree. At this particular point, phase will be now 90 degree. Now, particle will be coming back also. When the particle is coming back at this particular point, what will you face? Again, 90 degree. At this particular point, when it reaches, we have to add this. This is 60 and this is 90. So this angle we have to add it here. 60, 90, difference is 30. This difference we have to add it. That will be 120. At this particular point, what is our phase difference here? 15 degree. So here also it will be 15 degree. That is 135. If the particle is at this particular point, what will you face now? Phase of the particle will be like 135 plus this will be 150, and this side again the particle has completed half rotation, this will be 180 degree. So here if you talk about this, particle is over here. So in this case, what will you face? Again here difference is 30, here also difference would be 30, 180 plus 30, this will be 210 this side. So this particular point, when the particle reaches this particular point, the phase should be given by this 210. So if you talk about this 210, difference would be here, as the difference here is 15 degree, here also difference would be 15 degree, so this will be 225 degree. When the particle reaches this particular point, this will be 240 degree. 240 plus 30, how much? That is 270 degree. Okay, again it will be 270 degree. Now the particle is going back 270 degree. So this particular point 270 plus 30. So this will be 300 plus 15 degree. So this is 315 degree. And this one 315 plus 15. So this side 330 degree. And can you tell me at this particular point? 360 degree, right? So 360 degree means one complete oscillation. So this is starting from 0. And again at the same time, this is what we define one complete oscillation. And suppose if the one particle is over here. One particle is over here, that is at this particular point. So particle 1, I will be writing this. X is given by A sine omega t plus 45 going towards right side. And second particle is over here. Equation of this will be written by like this. X2 is equals to A sine omega t plus how much angle here we have? 210. This will be 210. So this is the equation of the motions that we are getting. The particle is starting from this position, A sine omega t plus 0. If the particle is start from this position, A sine omega t plus 90 degree. I hope this is clear to everyone. You can pause the video and you can note it down this particular diagram over here. So next, if we talk about this time analysis. So for this similar case, how much time it will take to go from one point to another point. So if I draw this again, so let's say x equals to 0, and here this particular side, I will draw a little bit bigger over here. This is x equals to A, and this side also the same story. The similar story should be on this side as well. That is x equals to minus A. Okay, so middle point is, let's say, A by 2, and this side one particular point A by root 2, and here this is root 3 A by 2. To go from x equals to 0 to A by 2, what is time that will be taken here? T by 12. Okay. To go from x equals to 0 to a by 2, time will be t by 12. Again, to go from this point to this point, again, time will be t by 12. To go from this point to this point, time will be t by 12. Like that, time is divided in 3 equal parts. So next, to go from here to here, that is x equals to 0 to x equals to a by root 2, time will be t by 8. And to go from x equals to a by root 2 to x equals to a, again time will be t by 8. And to go from here to here, what will be total time now? X equals to 0 to x equals to a by 2, that is t by 8 plus t by 8, that is t by 12. Whatever the time analysis that we have done on the right hand side will be equal to same this side as well. This will be minus a by 2, minus a by root 2, and this side minus root 3 a by 2. So this point to this point, time will be t by 12. Next, minus a by 2, root 3 a by 2, again time will be t by 12. So this side again time will be t by 12. Okay, x equals to a by 2 to x equals to a, time will be again t by 6 here. So time will be t by 6. T by 12 plus t by 12, that is t by 6. X equals to 0, any point you can calculate from here, and you can solve the questions in just minutes. This will be t by 6 if you know this particular. So this is t by 12, this is t by 4. X equals to 0 to x equals to a minus, this will be t by 4, right? So next we have, that is energy in the SHM. So if you talk about the energy in the SHM, we have, so what is the energy in SHM we have? So if you talk about this energy, and before that let's discuss the velocity and acceleration as well. So if you talk about if the particle is doing SHM in such a way that this particular point, that is x equals to 0, again this side x equals to a and this side x equals to minus a. So let's say particle at this particular point, how much distance from here? That is x distance from here. So particle at that particular point distance is x. So velocity of the particle is given by omega under root a square minus x square. So if they are asking kinetic energy, so kinetic energy will be given by half m v square. So half m omega square, this will be a square minus x square. They are asking what is acceleration? Acceleration is given by minus omega square into x, minus omega square into x. And if they are asking what is potential energy, the potential energy of the SHM is given by potential energy at this particular point, that is half m omega square x square. So this is the direct formula that we have. Half m omega square we write in terms of the k square also. Half potential energy is half k x square, and what about the kinetic energy? Half k x square, half k a square minus x square. So x equals to 0. If I put x equals to 0, I'll be getting velocity maximum. And what is maximum? Omega multiplied by a. At the same time, kinetic energy maximum. What is kinetic energy maximum? Half m omega square a square. X equals to a. And what about the acceleration? Acceleration value will be 0 because x value is 0 in this particular expression. Acceleration will be 0. What about the potential energy? The potential energy will also be 0. Next, if you talk about the x equals to a, when I am putting x equals to a over here, velocity will be 0 because a square minus a square velocity will be 0. And what about the kinetic energy? If velocity is 0 means kinetic energy will also be 0. What about the acceleration? A is equals to minus omega square a. If you talk about the magnitude, this will be maximum again. And what is the potential energy? This will also maximum half m omega square a square, because this is x equals to a. Again the same story this side. What is the velocity? 0, because x equals to minus a square is square cancel. What is the kinetic energy? This will also be 0. So this will be minimum kinetic energy at this particular point. So kinetic energy will be minimum, that will be 0. Next, if you have this maximum kinetic acceleration, what is acceleration? Minus omega square minus a, we are getting this acceleration is maximum. How much maximum? Omega square a. Here also acceleration is maximum. Minus sign signifies that acceleration is towards the left side, and here the positive sign signifies that acceleration is towards right side. Next we have the potential energy. So what is potential energy? If I ask you, potential energy is again x equals to minus a, so this will be half m omega square a square. Potential energy will be maximum at this extreme position and this extreme position, and kinetic energy will be maximum at mean position. Remember this: mean position, kinetic energy maximum, potential energy maximum. Kinetic energy maximum, potential energy minimum. Potential energy 0, and velocity maximum, acceleration will be 0. On the extreme position, velocity 0, kinetic energy 0. acceleration and potential energy will be maximum. So these are the pointers that we should keep in mind over here. And what about the total energy if we have? The total energy is always given by sum of the kinetic energy plus potential energy. So kinetic energy plus potential energy, that is total energy. So kinetic energy plus potential energy half m omega square a square minus x square plus half m omega square x square get cancelled. How much will you getting this? Half m omega square a square, that is the total energy, and this value is constant for SHM. If any object is doing SHM, means the total energy that we have to take it as constant. Remember this, total energy will be taken as constant. And the graph of this, so upward parabola will be given for potential energy. Remember this. So this particular point, that is x equals to 0, upward parabola, potential energy. This looks like downward parabola. The downward parabola will be for kinetic energy. So this will be for kinetic energy, and this will be for potential energy. Straight line that is touching the both kinetic energy as well as potential energy will be total energy graph. So this particular graph, that is the third graph, that is straight line that I have drawn over here, that is for the total energy. So this is for the total energy, this one is for kinetic energy, and this one is for potential energy. You can check x equals to 0. At x equals to 0, the potential energy is 0 and kinetic energy is maximum. Kinetic energy is maximum, and total energy is always constant, that is half m omega square a square. At this particular point, x equals to a, again the kinetic energy is 0 but potential energy is maximum. At this particular point, the kinetic energy is 0, potential energy is maximum, right? So they are equal of also somewhat. What is at this particular point they are equal, that is x equals to a by root 2. So this side is minus side, this will x equals to minus a by root 2, and this side, this is x equals to plus a by root 2. Clear? So moving next, so let's just solve some of the basic questions that we have from the equation of the SHM. Those is asked in previous year NEET papers. So x equals to phi sine omega t. So here we have x equals to phi sine pi t plus pi by 3. Comparing this equation with x equals to a sine omega t plus phi. Comparing this equation, what is it asking? Amplitude and time period. Obviously, whenever I am writing this particular equation, a is the amplitude, omega is the angular frequency, phi is the phase. So what is amplitude? Just calculate, that's it. Just compare this, a is equals to 5 centimeter. What is omega? Omega is given as 2 pi f, and that is given by pi. Pi or pi cancels, so 2f equals to 1. So what is f? 1 by 2. So 1 by 2 we are getting f. So 2 pi f, what they are asking? They're not asking frequency, they're asking the time period. So from here we can write, so what is time period? So what is omega here? Omega is equals to 2 pi by t. So what is, so this pi cancel, what is t? T is equals to 2 seconds, amplitude is 5 meter. Option B. Clear? So this is the basic question that we have from the SHM. Next we have, a pendulum is hung from the roof of the sufficiently high building and is moving freely to and fro like simple harmonic oscillator. The acceleration of the bob of the pendulum is 20 meter per second square at a distance of how much? 5 meter from the mean position. So pendulum is oscillating in a such a way that at a distance of how much? 5 meter from this. Acceleration value they have mentioned is how much? A is equals to minus omega square x, and this, if you talk about the mod, this will be omega square x. What is this x? X is nothing but 5 meter. At 5 meter, what is the value of the acceleration? They have mentioned that is 20. So this value is 20, and what is 20? Omega square into 5, right? What they are asking? Time period of oscillation. Compare this. What is omega square? This will be 4. So what is omega? 2. And what is omega? 2 pi by t. So here 2 or 2 cancel. How much you got? T is equals to 5 seconds. Your answer is option B. Clear? Your answer is option B. A particle executes linear simple harmonic motion with amplitude of 3 centimeter. Okay, on amplitude they mention is how much? 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity is equal to that of the acceleration. So if the particle is doing SHM, and let's say this x equals to 0 is its mean position, x equals to minus a this side, amplitude they mention, how much they mention? Okay, amplitude they mention is, that is x equals to minus 3 centimeter this side, and this side x equals to plus 3 centimeter this side. When the particle is how much distance? 2 centimeter from the mean position. When the particle is 2 centimeter from the mean position, so this particular distance is how much? 2 centimeter, means what is x value is? 2 centimeter from the mean position. At this particular point, the velocity and acceleration are equal as per the given in the given question over here. So what is velocity expression in terms of the x? A is equals to omega square into x square. And what is the acceleration? Omega square into x, because we have to take the magnitude, no need to worry about the direction, no need to worry about the sign over here. So 1 omega getting cancelled. So squaring both the sides, I'll be writing this a square minus x square equals to omega square x square. Okay, omega square x square. We have to substitute value as well. Whose value I have to substitute? 2 centimeter. Just substitute and find out the time period. That's it. So what is amplitude? 3 square minus 2 square is equals to 2 square into omega square. So this how much we got? 3 square minus, so this 9 minus 4, 5. 5 by 4 is equals to omega square. So this root 5 by 2 is equals to omega. And what is omega? 2 pi by t. So what is time period from here? This will be 4 pi by root 5. Clear? Again the answer is option B, 4 pi by root 5. The phase difference between the displacement and acceleration of particle in simple harmonic motion is given by, remember this, x is given by a sine omega t. What is the velocity? Velocity will be given by dx by dt. And how we can calculate this? Dx by dt. Differentiation of this will give omega a cos omega t. So if we talk about this will become omega a sine omega t plus pi by 2. And what is acceleration? A is equals to minus omega square x. So minus omega square a sine omega t. So this, if I take minus inside, this will become omega square a. This will be sine omega t plus pi. Sine omega t plus pi. Sine pi plus theta. Sine pi plus theta minus sine theta. Okay. So this side omega square a sine omega t plus pi. So this, what is the phase difference between this? Both are sine. Here also sine and here also sine. So what is the phase here? Omega t. What is the phase here? Omega t plus pi by 2. And what is phase here? Omega t plus pi. So if we talk about the phase difference here between the displacement and velocity, pi by 2. Between the velocity and acceleration, again pi by 2. What they're asking? Displacement and acceleration. So between these two. So this one is pi by 2, this one is pi by 2. So this will be how much? Pi radian. Clear? So this will be the phase difference between, you can note down this. Displacement, velocity pi by 2. Velocity, acceleration pi by 2. Displacement and acceleration will also be pi by 2. Right. Two particles are oscillating along the two close parallel straight lines. Two close parallel straight line like this. Okay. By side, line by side with the same frequency and amplitude. So this length and this length should be same because amplitude is same. They pass each other moving in opposite direction when their displacement is half of the amplitude. When the displacement is half of the amplitude. So this particular point x equals to a, and this also let's say x equals to a. So when their displacement is half of the amplitude. So this side a by 2, and this will be 0 degree, and this will be 0 degree. So when the displacement is half of the amplitude. So one particle is moving towards right side as per given question. I am not saying question is saying that. They are moving in opposite direction. So one particle is moving this way and another particle is moving this way. One particle is moving this, another particle is moving this way. So this particular question, if I see this one, just now we saw that time analysis we have. When particle is x equals to a by 2, what is phase here? 30 degree. And when the particle is coming this side towards negative x, what is phase here? 150 degree. So this particular point, that is what we got. So this particular question is saying that only. So this one is, what is phase? 30 degree. And what is phase here? 150 degree. What is difference in the phase, right? So what is difference in the phase? Delta phi. What is delta phi? 150 degree minus 30 degree. Answer is 120 degree. Convert into radian. So this will be 2 pi by 3. So answer is option C here. Clear all of you? So this will be under root 2 pi by 3. Right. A particle executes simple harmonic motion with an amplitude A. The period of oscillation is T. The minimum time taken by the particle to travel the half the amplitude from the equilibrium position. The minimum time taken by the particle, that is x equals to 0 to half the amplitude A by 2. Simple question they are asking, that is x to 0 to A by 2. Just now we discussed that. What are the different formulas that we discussed? What are different time intervals, that is time analysis that we discuss here? X equals to 0 to x equals to A by 2. How much distance, how much time it will take? It will take the time of T by 12. Okay, so it will take a time of t by 12. So this I'll be writing x equals to 0 to x equals to a by 2, time will be t by 12. That's it. That's it. No further question is asking. That's it. If they're asking for x equals to a by 2 and x equals to a, this will be t by 6. If they're asking from this, from here to here, that is t by 8. From this side to this side, that is again t by 8. So here we have the graph. If you talk about the graph is, let's say for example x equals to a sine omega t. We are looking like graph is starting from this x equals to a sine omega t, and what they're asking? Acceleration of the particle at t is 2 seconds. So they're asking acceleration of the particle at t is equals to 2 seconds. So from the graph, how can we find the acceleration? Remember this. What is acceleration? A is equals to minus omega square x. So what is omega and how can we calculate omega? Omega is simple. What is omega? Simple formula that we are using, that is 2 pi by t. And what is time period? Time taken to complete one oscillation. What is one oscillation? Time of one wave. So this is half wave, this is one wave. So from this point to this point, how much time we are taking? 8 seconds. So from the graph, t is equals to 8 seconds. So from this point to this point, that is 8 seconds. T equals to 8 seconds. Omega equals to 2 pi by 8. Okay, omega is 2 pi by 8. So putting this value over here, and at t is equals to 2 seconds, what is the x value? That also we have to focus. At t is equals to 2 seconds, what is the x value? At t is equals to 2 seconds, what is the x value? The corresponding x value is 1. As per the given graph, at t is 2 seconds, corresponding x value is 1. So x equals to 1. We want acceleration. What is acceleration? Minus omega square x. Just now we got omega, that is pi by 4. So pi by 4 square into x, and that too minus will come obviously, because we can't neglect, because option is there in terms of the minus. So this will be minus pi by 4 square. So this, how much we are getting this? Minus pi square by 16. Answer is option C. So body is executing simple harmonic motion with frequency n. The frequency of its potential energy, you can note down this, frequency of potential energy equals to frequency of kinetic energy is 2 times of frequency of oscillating bodies. Okay, 2 times frequency of body. So whatever the frequency we have, it will double up that. So this will be 2n. So time period oscillating bodies we have. The first one is spring mass system. If we have a spring mass system like this, if it is there, the spring mass system is like this if it is there. So here the time period is given by, so whether for this one, the time period is given by t is equals to 2 pi under root m by k. T is equals to 2 pi under root m by k. If we have a spring mass system like this, 2 pi under root m by k for this one as well as for this one. If the two masses are combined like this and it is oscillating, in that case, we'll be writing t is equals to 2 pi under root mu by k. And t is equal to 2 pi under root mu by k. What is mu here? Reduced mass. And what is reduced mass? m1 m2 divided by m1 plus m2. We can write directly m1 plus m2. So this will be reduced mass. So if the two masses are combining like this, we'll be writing this time period is 2 pi by under root mu by k. Next we have, that is, so SHM, it depends on the mass, it depends on the spring constant k. That we are going to do. If we have spring, if we have pendulum, simple pendulum we have. So simple pendulum. So in this case, simple pendulum we have, the time period is given by 2 pi under root L by G. The time period is 2 pi under root L by G, where L is the length of the pendulum over here and G is the action due to gravity. Now, certain cases that we have to discuss in this case. Suppose if this is kept inside the lift and the lift is going upward. If the lift goes upward, okay, lift moves up. Okay, if the lift moves up, then here we will writing G effective is equals to G plus A. And time period will be given by 2 pi under root L by G effective. In that case, if the lift moves down, if the lift moves downward with acceleration A, then time period will be writing G effective. And what is G effective? G minus A. And what is T here? 2 pi under root L by G effective. Again, so here G minus A and here G plus A. If stationary, again 2 pi under root L by G. If moving constant velocity, then also it will be 2 pi under root. If moving with constant velocity or stationary, it will be same. G effective will be G only, right? So these are the cases that we discussed that we have to focus in this case, that is spring, that is simple pendulum. If the mass of the bobby in simple pendulum is increased to thrice its original mass and its length is made half of its original length, then the new time period of the oscillator is x by 2. So what is time? 2 pi under root L by G. Okay, time period is 2 pi under L by G. There is no mass term over here. If we change the mass also, then nothing will happen. So what is focusing only on length? So time is proportional to root of L. Okay, so time will be proportional to root of L. What is happening? New time period. So T dash by T is equals to root of L dash by L. So T dash by T is equals to L dash by L. What is L dash? X by 2. So times original, sorry, this will become x by 2. Length is become half, no? So this will become 1 by 2. So what is T dash? So T dash will become from here, that is T by 4. So answer is option 4. Just a second. So this side, if you are getting this, T dash by T equals to 1 by 2. So what is T dash? T dash will become how many times? Half of its original length. So T dash will become T by root 2. Okay, so T by root 2. So x by 2 times its original time. So from here, so if the mass of the bob in a simple pendulum is increased to thrice its original mass and length is made half its original length. So length is made half, so time period will reduce by T by root 2 times. So new time period oscillation is x by 2 times of original. So what is x by 2 times of this? So x by 2 is equals to 1 by root 2. So what we are getting here, x equals to 2 by root 2. X equals to 2 by root 2. So what is x here? Root 2 times. So we are getting this x equals to root 2 times. Not option 4, option. The spring is stretched by 5 cm by a force of 10 Newton. The time period of the oscillation when a mass of 2 kg is suspended by it is. So time period oscillation when a mass of, so it is stretched by, so force F equals to K into X will be using this. What is the force that we are applying here? 10 Newton force we are applying. K, what is K? Into X is 5 centimeter from here. So from here we got the value of K, that is 10 divided by 5 centimeter. So this will be 10 divided by 5 centimeter, 0.05. So 0.05. So this 10 divided by 1000 divided by 5. How much we got? K value is 200 we got. What they're asking next? They're asking what is the next value? What is asking? Time period of mass, time period of spring mass system when we have, what is that? T is equals to under root 2 pi under root m by k. So T is equal to 2 pi under root m by k. So what is time period from here we can write? So this will be 2 pi under root mass, how much mass we have? 2 divided by, what is the K value? 200. So time period is given by 2 pi under root 1 by 100. So T is equals to 2 pi by 10. So 2 pi by 10 means pi by 5. So when we have pi by 5, what is the value here? So this pi by 5, so 3.14 by 5. The value will be getting, that is 0.628. So this we are getting 0.1. That is the simple formula that we are using here. Time period is given by 2 pi under root m by k. A body of mass m is attached to the lower end of the spring whose upper end is fixed. Okay, so lower end of the spring whose upper end is fixed. The spring has negligible mass. When the mass m is slightly pulled down and released, it is oscillating with certain time period. How much? 3 seconds. So at this particular point, what is time period? At this particular point, time period is 3 seconds. When the mass is increased by 1 kg, so right now mass is m, the mass is increased by 1 kg, the time period of the oscillation becomes 5 seconds. So what is time here? Time period is 2 pi under root m by k. Second case, in the second case, what is happening? The mass is increased by how much? 1 kg. So we are putting one more mass in that. The total mass will be m plus 1 kg. So what is time period now? T2 is equals to 2 pi. The K value will not change because K is a spring constant that depends on the spring material. Okay, so T is equal to 2 pi under root m by k. So this, what is the mass now? M plus 1 divided by k. So what is time? This is time is 3 seconds. You just divide the ratios, you will be getting the answer. T1 by T2 is equals to 2 pi under root m by k divided by 2 pi under root m plus 1 divided by k. So what is T1 by T2? What is T1 we are getting here? 3. And what is T2 we are getting? So when it is increased by 1 kg, what is the time period oscillation? That is 5 seconds. So this will be 3 by 5 is equals to root of m divided by m plus 1. So this side, so 3 by 5, that is 9 by 25 is equals to m divided by m plus 1. So solving this case, we'll be getting the answer. We're getting right 9m plus 9 is equal to 25m. This 9m plus 9 is equals to 25m. So from here 16m is equals to 9. So what is m? 9 by 16. Answer is option. So m will be 9 by 16. Clear? The simple formula that using T equal to 2 pi under root m by k. The spring of force constant k. The spring of force constant k is cut into length ratio 1 raised to 2 raised to 3. They are connected in series, and the new force constant k dash. Then they are connected in parallel, and the force constant k double dash. So what is k? So here we have spring constant is cut into length in the ratio. So one spring is there like this. It is cut into the ratio 1 raised to 3 raised to 3. So here the spring constant. So this will be 1. This will be second spring, and this will be third spring like this. So if this one is having spring constant k, what is the new spring constant? We are writing this Lk divided by L1. So this one is x. Here length is 2x. Here length is 3x. So I'll be writing this Lk divided by this. So what is total length? We can write in terms of here the total length that we can write here. So this is x, 2x, and 6x. So total length will be, this one is x, this will be 2x, and this one is 3x. What is total length? So Lk divided by L1. And what is L2? What is K2? Sorry, what is K2 here? The K2 is given by Lk divided by K2. And what is K3? The K3 is given by Lk divided by K3. Lk divided by L1, L2, and L3. So this side Lk divided by L1. This is Lk divided by L2, and this Lk divided by L3. So this side K1 value will be writing this. What is L total length? How much? 6k divided by x, 6k by 1. What is L here again? Total length, that is 6k divided by, what is L2? 2. And this side K3. What is K3? 6k. Total length is 6 divided by how much length of this? That is 3. 6k by 3. So we got 6k, we got 2k, and we got 3k. 6k, we got 6k, we got 3k, and we got 2k. They are connected in parallel. So first they are connected in series. So when they are connected in series, means it will give the same value k. When they are connected in parallel, so if they are connected in parallel, the k equivalent is given by 6k plus 3k plus k, 2k, right? So we are getting this 11k. So k in series, it is similar to this. So this k in series equals to k, and k in parallel will be equals to 11k. What is the ratio that we are having? That is 1 by 11. Okay, this will 1 by 11. So time period of mass suspended from a spring is t. The spring is cut into 4 equal parts. If it is cut into 4 equal parts, 1, 2, 3, and 4. So this one is having spring constant k. So this will be 4k. This will also be 4k. This will also be 4k, and this will also be 4k. So time period, respective time period is given by 2 pi under root here m by 4k. So what is time period here? T is equals to 2 pi under root m by k. So this is how many times of this? So this t dash is how many times of this? T by 2. Answer is option C. So here we have, that is when the two displacement represented by the y1 equals to a sin omega t, and second is y2 equals to a b cos omega t. So whenever this type of question is coming, we have to find what is the resultant amplitude whenever they're asking. So remember this, you can note down the formula. The resultant amplitude is given by under root a square plus b square plus 2ab cos theta, cos phi, 2ab cos phi. What is phi? Phi is the phase difference. Now, what is the phase difference between these two? This one is sine and this one is cos. So what is the phase difference between these two? Phi is given by pi by 2. Remember this. So one is sine and second is cos. The phase difference will be pi by 2, because figure with cos we can write in terms of the sine omega t plus pi by 2. So here the phase difference is pi by 2. Okay, the phase difference is pi by 2. Putting this value, the resultant amplitude is given by under root a square plus b square plus twice ab cos pi by 2. Cos pi by 2 value is 0. So what is resultant amplitude that we are getting here? Under root a square plus b square. So whenever we have this type of equation, a sin omega t plus b cos omega t, for that you can note down this resultant amplitude under root a square plus b square. So it is simple algorithm with amplitude under root a square plus b square. Yeah. So moving to next part, that is the waves part. So if we talk about this again, it is little bit similar to that SHM. So in this waves part that we are going to discuss, what is that? A wave traveling in the positive x direction with this much velocity is this much, lambda is 60. The correct expression for the wave is given by, so what is y? The y is given by amplitude is 0.2, right? So any wave equation can be written in this particular format. So y is equals to a sine omega t minus kx plus phi. Any equation can be written in this particular format. What are different terms? A should be amplitude. So all of we can check all the amplitude is how much. So here y is 0.2. So here positive expression with x, a is equal to 0.2 meter per second, velocity is 360 meter per second, lambda is 60. So here this particular term, that is omega. What is omega? 2 pi f, that is 2 pi by t. So we have to check this. We have to check different equations from here. So this one, I'll be saying that a is 0.2 meter per second square. What is velocity? 360 meter per second. So let's check this. The velocity of the wave is given by, velocity of the wave is given by, that is the coefficient of t by coefficient of x. Coefficient of t by coefficient of x. So who is there with t? By who is there with x? Coefficient of t by x. So what is coefficient of t? 60. So this side 6 divided by coefficient of x 1 by 60. So this also correct. We are getting how much? 360. This also we are getting correct. They are traveling in which direction? Positive x direction. Positive x direction means whenever they are traveling positive direction means omega t term and x term should be having same sign. So as it is should be having different sign. So this one is not possible because this one is having positive, this is also positive. This is also not possible because this is also positive, this is also positive. This one and this one both are positive over here. So here out of this option is wrong. This C and D that we have to focus over here. And what is the coefficient of t by coefficient of x? There is one more term that we can use here. What is that? Lambda value. What is lambda? 60. And how we can get the lambda? If you compare this, lambda is given by from here. K is equals to 2 pi by lambda. Okay, K is equal to 2 pi by lambda. So if we multiply this 2 pi into this, so from here, if I talk about the option C, option C, so 2 pi x by 60 is equals to 2 pi lambda into x. So compare this, 2 pi cancel. So what is lambda? We got 60 we got. So this particular answer is option C because we are getting the lambda value how much? 60. And if I compare this one, so this will be pi x by 60 is equals to 2 pi by lambda into x. This x cancel, pi cancel. So what is lambda? 120 from here. Lambda is 120 from here. So this particular question will not give the lambda value 60. Okay. A transverse wave is represented by the y equals to a sin omega t minus kx for what value of the wavelength is twice if the wave velocity equal to maximum particle velocity. Wave velocity is equal to maximum particle velocity. So Vp max. So what is Vp in general? Pi by 8. So omega a is the maximum particle velocity for what value of wavelength is the wave velocity equal to. And what is wave velocity? Coefficient of t by coefficient of x. So coefficient of t by coefficient of x, that is the wave velocity we have. So coefficient of t, what is coefficient of t? Coefficient of t here is omega and this one is k. So from here if I write this omega a, that is the wave particle velocity, should be equal to wave velocity. And what is wave velocity? Omega times up. So from here omega cancel. So what is this? I will be writing k into a is equals to 1. What is it asking for? What value of the wavelength? What is k? Propagation constant. What is that? 2 pi by lambda into a is equals to 1. So what is lambda? 2 pi into a. Okay, so lambda will be 2 pi into a. Two waves are given by this equation, that is y1 equals to a sin omega t plus kx plus 0.57 and second is a cos omega t. So they're asking this y1 a sin of this omega t plus kx plus 0.57, and second is y2. Again, so whenever they're asking the phase difference, remember this always what we had to focus. This should also be sine and this should also be sine, but here this one is sine, this one is cos. How can we convert this cos to the sine? Just add this a sine omega t plus kx plus again pi by 2. Your problem will be solved now. What is the phase here? Omega t plus kx plus 0.57. What is the phase here? Omega t plus kx plus pi by 2. The phase difference, that is delta phi, that I am writing here, omega t plus kx plus 0.57 minus omega t plus kx plus pi by 2. So if we solve this, if we subtract this, this will get cancelled. So 0.57 minus pi by 2, that is 1.57. What is we are getting? Minus 1. So if we look at the options, we are getting 1 radian, that is the phase difference between those two waves. Clear? So intensity of the wave, whenever the two waves are combining at one particular point, so maximum intensity, resultant intensity, maximum intensity, you can note down this, that is root of I1 plus root of I2 ka whole square. And what is minimum intensity? The minimum intensity is given by root of I1 minus root of I2 ka whole square. What they are asking? The sum of the maximum and minimum intensity. So just adding this, so this will be I1 plus I2 plus 2 root of I1 into I2, and this side this will be I1 plus I2 minus 2 root of I1 into I2. If we add both of this, what will be getting this? Adding this I max plus I minimum. So this will be getting here 2 times of I1 plus I2. Here the 2 times of I1 plus I2, that we are getting option B over here. Next we have intensity of a waves. Intensity of a wave. So for example, let's say this is the particle from which the waves is, this is sound wave for example. Let's say wave is radiating in all possible direction. So this is the point source. Okay, this is the point source. The radius wave, the wave is radiating all possible directions. So at this particular point, suppose if they're asking what is the intensity, how it depends. So intensity is proportional to what? For point source, intensity is proportional to 1 by r square. Okay, intensity is proportional to 1 by r square for the point source. So they're asking for the distance of 2 meter and they're asking for distance of the 3 meter. So here I2 by I1 is equals to R1 by R2 ka whole square. So if we talk about this I2 by I1, so what is I1? So we'll be writing this at a distance of I1 by I2, sorry, though this will be, I can write intensity is proportional to 1 by r square. So initially how much distance? 2 meter and 3 meter. So here I'll be writing this I1 by I2 is equals to R2 by R1 ka whole square. So that's it, R2 by R1 ka whole square. So what is R2 by R1? R2 by R1, so R2 3 by 2 ka square, we are getting how much? 9 by 4, that is I1 by I2. So this is the ratio of the intensities we have, that is 9 by 4. Where the intensity will maximum? At 2 meter near the source. As we are moving away from the source, the intensity will keep on reducing. Transverse waves on a string. So transverse waves on a string, we have the formula, that is formula is given by speed of transverse on the string is given by v equals to under root t by mu. Okay, so transverse on the string is given by v equals to under root t by mu, where t is the tension on the string and mu is the mass per unit length. Now, so as per the given question over here, what is actually happening? Uniform rope of length L and mass m1 hangs vertically from the rigid support. The block of mass m2 is attached to the free end of the rope. A transverse wave pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope is given by lambda 2. So here one block is attached and the given a block of mass m1. So just a second. So at this point of time, one block is attached here m2 and they have mentioned what is that? Uniform length of this mass is m1. So this mass is m1. So one wave is formed on this particular string. As it is going up, tension is increasing. At this particular point, tension is given by only m2g. Okay, and at this particular point, tension is given by m1, that is the mass of the rope will also be counted plus this m2. m1 plus m2 into g. So this tension is T1 and this tension is T2. And we know what is velocity. Velocity goes under root T by mu. And what is velocity? Frequency into lambda. So mostly frequency does not change from one medium to another medium because frequency depends on the source. So lambda is proportional to root of T. So lambda 2 by lambda 1 will be given by, what is that? T2 by T1. Okay, so T2 by T1. What is T2? So here under root m2 plus m1 divided by m1. So answer is option divided by m2, right? Divided by m2, because at this point what is T1? M2g, at this point T2. Under root m1 plus m2 divided by root m2. A string is stretched between two fixed points separated by how much? 75 centimeter. It is object to have the resonant frequency of 420 hertz and 315 hertz. So this we have 315 hertz and here we have 420 hertz. There are no other resonant frequencies between these two. So we have different types of harmonics over here, that we have first harmonic, second harmonic, third harmonic, fourth harmonic, like that we have. So we have to check. So for example, let's say the first harmonic, third harmonic we don't know. Okay, the first harmonic for this we know, that is f equals to v by 12. Next will be f equals to 2v by 12. Next will be f equals to 3v by 12. Like that we have relation over here. So if I subtract this one, this is f2 and this one is f3. If I subtract this one, what will be getting? This f3 minus f2 or any other two consecutive frequency. If I subtract this one, I'll be getting this 3v by 12 minus 2v by 12. So what is that? V by 12. And what is V by 12? That is the fundamental frequency of the string fixed on the both the string. So here, what is difference we are getting? So 315 minus 420. What is difference we are getting? Minus 315. What is the difference we are getting? 105 hertz. Okay. So first one is, first fundamental frequency is 105 hertz. Next will be 105 double of this, that is 210 hertz. Then triple of this will be third harmonic and this will be fourth harmonic. The lowest resonant frequency will be, that is fundamental frequency, 105 hertz. Just subtract that, we'll be getting the answer over here. So if N1, N2 and R3 are the fundamental frequency of the three segments into which a string is divided, then original fundamental frequency of the string is given by. So here, if we divide the strings in different parts over here, so at this particular point, N1, N2 and N3 are the fundamental strings of the string. So for example, a string is divided in this part. This length is, let's say, L1, and this length is, let's say, L2, and this length is, let's say, L3. So what is fundamental frequency for this N1? I'll be writing this V by 2L1, and for this N2, what is that? V by 2L2, and for this portion of the length N3 is equals to V by 2L3. What is V by 2L? That is the fundamental frequency of the length. So from here I can write, so from here we can write, what we can write? N1 equals to V by 2L1, N2 equals to V by 2L2, and this side N3 equals to V by 2L3. So from here we can write, what is L1? V by 2N1. And what is L2? V by 2N2. And what is L3? V by 2N3. Okay. And if I talk about this complete string, what will be fundamental frequency for this? That is, fundamental frequency N will be given by V by 2L. What is L from here? V by 2N. So just normal addition, L1 plus L2 plus L3 will be total length L, right? So this L is given by L1 plus L2 plus L3. Putting this value, so L is given by this, L is L1 plus L2 plus L3. So what is L? V by 2N. So V by 2N is equals to V by 2N1 plus V by 2N2 plus V by 2N3, V, 2, cancel everywhere. What we got finally, that is 1 by N1 plus 1 by N2 plus 1 by N3 is equals to 1 by N. Reciprocal of all the frequencies will be added like it. So answer is option A. 1 by N1 plus 1 by N2 plus 1 by N. An organ pipe filled with gas at 27 degrees resonance at 400 in the first fundamental mode. If it is filled with the same gas at 90 degrees Celsius, the resonant frequency of the same mode will be given by. So initially it is at temperature T1. So what is temperature T1? 27 degrees Celsius, that is 300 Kelvin. it is having resonance frequency how much? 400 hertz. Okay, it is filled with the gas at 90 degrees Celsius. What is temperature now? 90 degrees Celsius in this case. So this will be 273 plus 90 that we are getting here. How much we are getting this? 363 Kelvin. Okay, so 300 Kelvin. Again, the fundamental frequency, the resonance frequency at the same mode will be given by. So what is resonance frequency in this particular case? So this 363 hertz. So what is changing? What will be changing here? Speed will change. Speed of the sound will change. And how the speed of the sound will change? V is proportional to under root gamma RT by M. Okay, V equals to under root gamma RT by M. So what is fundamental frequency? The fundamental frequency is proportional to root of temperature here. Okay, so fundamental frequency is fundamental frequency is given by V by 12. So this is given by under root 1 by 12 under root gamma RT by M. So frequency is proportional to root of temperature. That's it. So fundamental frequency final, that is F2 by F1 is equal to root of T2 by T1. So solve this particular case, that is 360 by 300. Approximately how much we are getting this? 1 divided by 100 root. How much we got? 11 by 10. So F2 by F1. So first fundamental F2 by F1 is equal to 11 by 10. So what is F2? 11 times of F1. Okay, 11 by 10 times of F1. So when it is 400 hertz, it is frequency is 400. 27 degrees Celsius frequency is 400. So this F2 by 400 is equal to 11 by 10. So we are getting this. What is F2 value? 440 hertz. Okay, 440 hertz. So this will be F2 value. The fourth overtone of the closed organ pipe is same as the third overtone of an open organ pipe. So here we have closed organ pipe, and fourth overtone of the closed organ pipe is same as the third overtone of open organ pipe. Third overtone of open organ pipe. The ratio of the length of the closed to length of the open pipe. So this, let's say length is LC, and let's say this length is L0. Okay. So if you talk about the base frequency V by 4L. Okay, this is the base frequency. Next, first overtone, it is only having odd harmonics 3V by 4L. So this will be 3V by 4L. Next one, this is first overtone. Next one, 5V by 4L. Next one, 7V by 4L. This is base, first overtone, second overtone, third overtone. Next will be 9V by 4L. This will be fourth overtone. Okay, this is fourth overtone, right? And what are this one? Third overtone of this. So its fundamental is V by 2L naught. Second, first harmonic is V by 2L naught. Second harmonic V by 2L naught. 2V by 2L naught. Third harmonic 3V by 2L naught. Fourth harmonic 4V by 2L naught. What they're asking? Fourth overtone. No. Third overtone is the fourth harmonic. So this will be third overtone. This will be fundamental, first overtone, second overtone, third overtone. So what? Now let's equate this. So this is fourth overtone. We are getting 9V by 4LC is equals to third overtone of this, that is 4V by 2L0, right? So what they're asking, ratio now, the answer is, so this V and V getting cancelled. So how much we're getting this? This 2 and this 2. So LC by L0, LC by L0 will be getting how much? This 2 will come this side, 9 by 8. Okay. LC by L0 is 9 raised to 8, right? Resonance column experiment. So there is one formula, V is equals to, you can note down this, 2F0 into L2 minus L1. So this is a direct formula. One or two times they have asked in NEET, previously NEET, this particular formula say question. So what is that? V is 2F0 into L2 minus L1. Read the question now. A tuning fork is used to produce a resonance in glass tube. The length of the air column in this tube can be adjusted by variable piston. At room temperature of how much? 27 degrees Celsius. Two successive resonances are produced at 20 centimeter and 70 centimeter. So length L1 is 20 centimeter and this length L2 is 73 centimeter. This is the two resonance length we are getting. If the frequency of the tuning fork they have mentioned So f naught in this case, the frequency of the tuning fork, that is 320 hertz. So there is direct formula V equal to f naught. So in that case, if I talk about the process, so there will be one resonance column exponent over here. So in this case, what will happen? There will be one tuning fork, and this side will be having water. Okay. So what is the role of the water? The role of the water is given by the role of the water is to make it closed. So at first we'll be getting first resonance column at this particular point, in which the resonance happens for the oscillation of the air molecules and the vibration of this tuning fork. So when the frequency of this tuning fork matches with the frequency of this, then we'll getting resonance length over here. After some time, when the water column goes down, then again there is one more resonance that is occurring over here. When the water column goes down, so this particular point length is L2. So for this we call it as one resonance length, and this is what we call second resonance length. So this L2 minus L1, that is V. From here we can calculate direct speed of the sound. So 2 into how much? Calculation part, 320 into L2 minus L1, that is 73 minus 20. So whatever the value we are getting, that is 640 multiplied by this 53, that will be the answer over here, L2 minus L1. So this particular case that we can solve anyway, 640 multiplied by half, it will be something like 330, more than 330, answer is 339 meter per second. Okay, so this is in 0.5. Okay, so last part, that is beats part over here, that is beat frequency. If we talk about this, so if we have the beat frequency, the frequency of the beats is given by difference in the two frequency of any two vibrating bodies. What we have difference the two frequencies, what we define? Beat frequency. And beat frequencies also we define the number of beats produced per second. Number of beats produced per second. So what is beats? So example, for example, this is the superposition of two waves which is traveling in the same direction. Okay, which is traveling in the same direction. Superposition of two waves which is traveling in the same direction. This is beat frequencies we define, where we'll getting sometime intensity of the sound is maximum and sometimes intensity of sound is minimum, just like siren of the ambulance. Sometimes intensity of the sound is maximum and minimum. So that is what we define beats. And let's solve this question from here. In guitar, two strings A and B. So here, whenever you're solving this particular problem, so this side known and this side it will be unknown, you make like this, and here you write beats. Okay. So in guitar, two strings A and B made up of same material are slightly out of the tune and produce beats of frequency 6 Hz. Okay. When the tension is B slightly decrease, the beat frequency of A is decrease. The original frequency of B is slightly decrease. So the beat frequency decreases to slightly decrease. The beat frequency decreases to. The beat frequency increases to. Here we are writing that as per the given question, it should be 7 Hertz. Okay, increases to 7 Hertz. Beat frequency increases to 7 Hertz. The frequency of A is 530 Hertz. So initially we know that is 530 Hertz. And what is beat frequency? So what is 530 Hertz? What is beat frequency? Here we have that is 530. The possible values, this will be 536. Unknown value 530 plus 6 or 530 minus 6, that is 524. Now when the tension in B, so what is tension in B? So V is equals to under root T by mu. Okay, V equals to under root T by mu. So from here we can calculate frequency is equals to V by 12, and that is given by 1 by 12 under root T by mu. So frequency is proportional to tension. So tension in B is decreasing. So as per the given, this question should be modified like this. So this particular question, that beat frequency increases to 7 Hertz on decreasing this slightly. B is slightly decreased, the beat frequency increases to 7 Hertz, and what is that? Frequency of A is 530 Hertz. Okay, frequency of A is 530 Hertz. They have given in the question. So if we are changing this, so this we are not changing, that is A frequency is not we are changing, this will be 530 Hertz. Beat frequency increases to 7 Hertz, so this will be 7. So what is the beat frequency 7 Hertz? So what is the possible now? So this will be 537 and this will be 523, right? So here beat frequency is 6 and here it is 7. So 530, this also 530. So it is slightly decreasing, right? It can't decrease from 536 to 537. This decrease is not possible. Why it should decrease? Because tension is decreasing. Tension in B is slightly decreasing, so frequencies will also decrease. frequencies will also decrease. 536 to 536 not possible. 536 to 523 possible, but tension is slightly decreasing, so frequencies should slightly decrease. So here the frequency slightly decrease, only one value, that is 524 to 523, it will decrease. So the original frequency of B will be, answer is option A, that is 524. So like this we have to approach the problems, known, unknown and bits. So that's it for today we have. So tomorrow we'll be coming with this chapter again. So little bit bigger chapter, electrostatics, because we'll be having in this, we'll be discussing with what is Coulomb's law, electric field, electric flux and Gauss law and their application. Then we have electric potential and potential energy, as well as might be discussing this capacitance part as well in this electrostatics tomorrow. So till now what we discussed, that is class 11 syllabus. We tried to cover in some of the in this session we try to cover some of the class 11 chapters. Tomorrow we'll be starting, from tomorrow we'll be starting class 12 chapters. Till then you prepare well, and as the days are approaching, don't just give up on solving the problems. Keep on practicing the problem as much as you can. So ultimate, the revision is only important. Whatever done is done. So I'm wishing you all the best. We'll see you again on a new video, right?